Okay, now we're going to talk about higher order derivatives. So let's start off with a basic function like x to the fifth power plus 3x to the fourth power minus 2x plus 1. And let's say this equation, for some reason or another, models the distance a particle travels. Models distance as some sort of function of x. All right, now we want to find out what the derivative is. And the derivative in this case, the first derivative, has a physical interpretation. In this context, since we're talking about distance, the derivative of distance is velocity. So if we wanted to find the velocity equation, we would simply take the derivative of the distance equation. So we have 5x to the fourth plus 12x to the third power minus 2. Now let's say we wanted to find the acceleration. So the second derivative, which is just the derivative of the derivative, the derivative of the first derivative, that's, in this example, can be interpreted as acceleration. The only reason I'm giving you these over here, distance, velocity, acceleration, is to let you know there are physical applications to the first derivative and the second derivative and so on. They won't always be the first derivative is velocity. It's only if the original function is distance that you get the first derivative as velocity. The first derivative could be something else entirely. But for this example, it's illustrative. It's illustrating the relationship from distance. You take the first derivative, you get velocity. You take the second derivative, which is the derivative of this function, you'll get the acceleration. So the derivative here is just 20x to the third power plus 36x squared plus the derivative of a constant is 0. So this would be your acceleration. It turns out if we wanted, there is a physical interpretation of the third derivative. If you start off with distance, first derivative is velocity, second derivative is acceleration. The third derivative is what's called the jerk. And the jerk is just talking about how much wiggle, if you will, or back and forth or jerking an object is doing during its acceleration. And that's in fact, so if you think of something falling out of the sky, in a vacuum it's going to move smoothly through acceleration, but in reality with other factors and forces there's something else going on and you're going to have some wiggle of the object, some jerking of it, if you will, as it's accelerating to the ground. And that's what the third derivative is. And in this case it would be 60x squared plus 72x. And that's the third derivative. We could keep going. And in this case, we won't be going on forever because we'll see soon that we run out. But let's say we wanted to find the fourth derivative. We could write 4 little hash marks, but that starts to get a little redundant or a little tedious rather. So we can write a little parentheses 4 to imply the fourth derivative. And that's 120 times x plus 72. The fifth derivative is 120. And the sixth derivative is 0. And all the rest of them are 0. Because once you get to 0, they're just going to go flat to 0. So in this case, we eventually got to 0. That won't always happen. I'll give you an example right now, in fact. If we start off with, separate, give us a little room here. If we start off with the function e to the x, and we took the first derivative, we get e to the x. And you can see where this is going nowhere fast, you get e to the x. and you keep going on forever. And in general, the nth derivative of e to the x is e to the x, period. You can keep going on forever and you'll never get anywhere. You could get some that go back and forth. If, for instance, you start off with the sine of x, the first derivative is the cosine of x. The second derivative is negative sine of x. The third derivative is negative cosine x. There is actually a repeating cycle. This does repeat in cycles of 4, it turns out. The derivative of, if you just ignore the negative sign for a second and take the derivative of cosine, you'll get negative sine. But with a negative in front, that becomes positive sine. And then you'll notice they start to repeat now once I've gotten to the fifth derivative. That's cosine. The sixth derivative is negative sine. And the seventh derivative is negative cosine. So what happens in this situation is the derivatives repeat in cycles of 4. So in one example, you had the derivative kind of eventually going down to 0. In another one, it stayed put, never got anywhere. And in a third case, we showed how they repeated in cycles of 4. You get sine, cosine, negative cosine, sine, cosine, negative cosine, and it repeats and so forth. So in this case, you've seen different ways of getting the higher order derivatives. In general, you start off with the original function. You take the derivative to get the first derivative. You apply the derivative to the original function. The second derivative is just the derivative of the first. The third derivative is the derivative of the second. So there's no need to go back to the original and apply these in multiple ways.